Okay, so you just got your new packets. Go ahead and jump forward to chapter 9.5 in the notes. We're going to go over this section on video today because it's pretty simple, and I think you guys won't have any problem duplicating this without me being here. As you can see, I've already started, but I had some lady come knock on my window and interrupt my video, so we're going to start over again. Talking about line symmetry, and line symmetry is kind of think about folding an object. If I fold it, can I fold it exactly where the left side will match up with the right side, or will the top match with the bottom? Or if I fold it in a diagonal, will the diagonals fold it exactly where it'll match up on both sides of that fold line? So that's kind of what we're going to be that's exactly what we're going to be talking about today. So line symmetry, a heart's a really good example. Most of us learn how to make a heart by folding our paper in half and cutting one half of the heart. We open it up and boom, we have the perfect heart. So line symmetry is going to be that line in which we cut an object in half so that it matches up perfectly. Let's look at some of our examples. So let's look at this very first one. We're going to see if it has line symmetry. If I was to try cutting it in half like this, would that match up perfectly? Well, no, it's not going to match up. But if I cut it in half down the middle, my left and my right side will match up perfectly. Thanks. Okay, videos. So I would have one line of symmetry. Let's look at B. So I'm going to look at this one and say, can I try cutting it this way? Does that work? Are they going to match up perfectly? Well, if I fold my paper, this is kind of going to come over this way, and this one's going to go this way. It's kind of going to be skewed. So I can't do top to bottom. So let's see about if I go like this. Well, if I cut it this way, is that going to work? Well, if I fold it over, this point's going to be hanging out further than this one, and this one's going to be shorter than that one, so that's not going to work. Let's just make sure diagonal's not going to work. So if I try going from diagonal to diagonal, this one's going to this corner's going to come up here and not match up with that one, so this one has no line symmetry. Okay, let's look at our star. Okay, so we have a starfish down here. And the first thing I'm going to do is see about cutting it from top to bottom. Okay, so if I cut it from top to bottom, is it going to match up? Yeah, it is going to match up. So can I cut it from here to here? Across this way? If I cut it across the middle, these are not going to match up. And I kind of have this one hanging out in the middle. It's not going to work. But if I go diagonal, that one will work. Go like this, that one will work. And I can even go down the middle of this one, and that one will work. So my question would be is how many lines of symmetry do I have? Do I have 1, 2, 3, 4, 5, 6, 7, 8? Oops, that looks like I missed one. Let's go ahead and add that one in there. So do I have 10 lines of symmetry? Let's think about that. Up here, did I have 2 or did I have 1? I only had 1. So, in this, every time on the test, this will happen. Someone will draw this line, these lines out and have them drawn perfectly. And then they'll ask how many, and they'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, 10 lines. That's not right. This one's 1, and this is the same 1. This line is 2, and it's the same line as this one. This one's 3, it's the same line as this. 4, this is the same line, and then 5. This is the same line as well, okay? So please don't get that confused. So this one only has 5 lines of symmetry. Let's look at 1A. So 1A, I could actually go here, and I could go here. So this one would have 2 lines. So let's look at our B. The only part that I can't do up and down, diagonal's not going to work, but I can go ahead and cut it here, and this part would match up exactly. So this one would have one line. Now, this next one has been a point of argument in the past. So some people think the stars line up exactly. Other people think the stars are just a little bit off. I think you can probably make a pretty good argument both ways. As of right now, the only way that I see that you could break this up would be like this. Okay, if my line was a little bit straighter. Now, people have made the argument that the way these stars are set up, you can't cut them in half evenly. I agree with that. I don't think that was the intentions of the book because they do go by the one line, but I do think there's a good argument for both of those. Okay, I would not put something like this on the test that could easily be miscued and taken either way. All right, so that's line symmetry. So let's flip to the back of the notes. And the last thing we're going to talk about is rotational symmetry. So rotational symmetry is like if I take a shape and I rotate it. So I'm just going to take this little sticky pad and we're going to talk about its rotational symmetry. We're going to say that it's a perfect square. Okay, just for argument's sake, it is a perfect square. Rotational symmetry means that I can rotate it less than 360 degrees because I agree that anybody can take any item and rotate it all the way back to where they started and boom, I have rotational symmetry. Well, that's not the way it works. It has to be something between 0 and 360. So it has to be less than that 360 degrees. So if you think about it, I could actually, I'm going to label these 1, 2, 3, 4. I can actually do one turn and I have rotational symmetry, meaning this shape here is identical to where I started. Okay, not only can I rotate it once, I can rotate it again, and this shape is identical to where I started. So I have 1, 2, guess what? I can probably go one more time, 3. This shape is identical to where I started here. Also, I could go 1, 2, 3, 4, back where I started. Okay? Now, if I was to use my phone, however, my phone is not a perfect square. It would be a rectangle. So if I rotated it one click, this shape is not identical to what I started with. However, if I go one more, this shape is identical. Pretend like these little, flaws. We're just looking at the shape as a whole. Would be exactly where I started. So this shape turned upside down is the same as this one right here. So I have one turn, now I'm back. So I had 180 degrees that I could rotate that and be back where I started. So that's kind of what we're going to be doing with these shapes. It's going to be a little bit harder because it's going to be on our paper, and some of us are going to be a little bit better at this than others, but that's okay. We'll get the hang of it. So let's look at A. So one way to think about it is let's find, first of all, does it have line symmetry? And if it does, where is that line symmetry at? That will help sometimes, but not all the time. If I look at this one has 0 line symmetry, but I do agree that I could rotate this all the way to this spot, and then I could take this spot and rotate it all the way up, and it would look exactly the same. And that's less than 360 degrees. So if I took my paper, and remember, this one's pointing up, this one's down. I rotate my paper. That doesn't work. One more time. Look, pointing up, pointing down. Okay? So I do have rotational symmetry, and it wants to know the angle of the rotation. Well, think about it this way. I had 1, 2 turns. So if I take 360 divided by the number of turns, I will have the angle of rotational symmetry. In this case, I had 1, 2 turns, so 360 divided by 2 equals 180 degrees. So that would be my rotational symmetry. So let's look at my M. Is there any way that I can rotate this M less than 360 degrees that will look exactly like this? Well, let's just take our paper and try it. So, have it this way. There's one. That doesn't do it. Now I got like a W. Now it's pointing the wrong way. Well, yeah, now it looks the same, but I went 360 degrees. So, does that count? No. So this one has none. All right, let's look at C. So now we have this snowflake. This is kind of where your lines of symmetry can help you. I agree that if I could rotate this to here, this one I could rotate to here, which would move this one to here, and this one to here, and then this one goes up here, and so on, and we're back to the very beginning. Now, how many turns did I make? I made 1, 2, 3, 4, 5, 6. So 360 divided by 6 would be 60 degrees. Now, this is a little different than line symmetry, because if I was doing line symmetry, I could cut it here through every single one of those, and I could do the middle. But remember, when we're talking about rotational symmetry, however I rotate it, it has to look identical to where I started. And if I don't do this all the way to this next one, it's not going to look identical. I do agree, though, that there is line symmetry here, here, here. But if I rotate, it's not going to give me the same shape. If I go from here to here, that is not the same shape that I started with. So remember, it has to look exactly the same as where you started. All right, so let's look at this one. On here, pretend like this strip is exactly identical to these. That's kind of been an argument in the past. So I can rotate here, here, here. So I have 3 rotations. So 360 divided by the number of turns, which would be 3, leads me to 120 degrees. Let's look at 2B. Can I rotate this one so that it looks exactly the same without going to 360? Absolutely. This one goes to here. This one goes up here. I've done 2 rotations. So 360 divided by 2 is 180 degrees. What do we think about this one? So the very last one would be a triangle. Is there any way to rotate this triangle less than 360 so that it looks identical to what it looks like right now? Well, let's try it. Let's try one click. That doesn't look like how it started. Let's try this one. That's not how it started. Let's try this one. Yeah, that's not how it started either. And it doesn't look the same until we get right back here. That's a whole turn. 360 doesn't count, so none. All right. Describe the symmetry of each. Draw the shape, copy the lines of symmetry and the rotation. Okay, so on this one, what they want us to do is talk about the rotational symmetry and the angle. We're not really worried about order. I'm not worried about that. I want to know if you can find rotational symmetry and if you can find line symmetry. So when we talk about rotational symmetry, I'm going to do pink. So this one would go from here to here. I have 2 turns divided by 360. So my rotational symmetry would be 180 degrees. My line symmetry, however, is saying we're going to pretend this is perfect, okay? It's supposed to be perfect according to the book. We could split it here, and I could split it here. So I would have 2 lines of symmetry. All right, so let's look at 3A. Now, if we're looking at this as the pattern and having to match the pattern up, that changes things a lot. If I was looking at this as just a circle, there would be an infinite amount of lines of symmetry for a circle because a circle is going to be infinite. They are looking at the slices, though. They are wanting you to go from here to here, to here, to here, to here, here. Okay, so we have, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 360 divided by 10 gives me 36 degrees. That would be my rotational symmetry. Now, my line symmetry, there's a lot of them. I could do this. I could do every single divider. And then I could go in between all of those. That would still make sure everything matched up. Now, the trick here is when you go to count these, do not count the lines twice, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. No, it should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 18, 19, 20. Okay, so I said don't count them twice, and I know you're thinking, well, then why did you count them twice? Because I know that it's exactly half of 20. So I have 10 lines of symmetry. All right, let's look at this one. So let's do our rotational symmetry. I could go 1, 2, 3. So 360 divided by 3 would be 120. My line symmetry, I could cut it here, here, and here. So this time I have 3 lines of symmetry. All right, let's do this last one, then you can get going on the homework. So for here, rotational, I would have to go by the picture. So I have 1, 2, 3, 4, 5, 6, 7. So 360 divided by 7 equals, let's see, 3 goes into there. 5 times 1, 3. It's going to just keep repeating. So 51 3/7. Okay. You could turn that into a decimal if you wanted. 1, 2, 3, 4, 5, 6, 7, which would be fine. Our line symmetry we could do here, here, okay. Now, after doing that, I could also, that's all of them, okay? So let's count the number of lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there was 14 lines. I don't want to double count them. I know that each of those has a beginning and an end. 14 divided by 2 would be 7 lines total, okay? So for tomorrow, you are going to do page 637. You will do both the front and the back. That is due tomorrow.